Hello everyone, welcome back to Math Specs. My name is Stephanie and today we're going to continue our Algebra 1 series. We're going to begin our discussion on translating words into mathematical symbols. So let's get started. So we're going to begin by discussing some addition vocabulary. On the left-hand side, you'll see that we have 4. We have sum, more than, plus, and increased. And in the middle column, we have our examples of how we use these in phrases. So the sum, so here's our word, the sum of 6 and a number tells us that we're going to be adding 6 and a number. So that's pretty straightforward, right? But how would we represent that? So we'd write 6 plus x or x plus 6. In the second bullet point, we have 8 more than a number. So here is our vocab word. So we're going to add 8. More than tells us it's addition and a number. So how would we represent that? X plus 8 or 8 plus x. In the third bullet point, we have a number plus 5. So we're going to be adding a number plus tells us it's addition, and 5 is going to be the other number we're going to be adding. And to represent that, it would be 5 plus x or x plus 5. And finally, in our last bullet point, we have a number increased by 7. So increased by tells us actually that we're going to be adding what? A number and 7. So let me go ahead and make this a little bit more clear. Increased by, there you go. So how are we going to represent that? It'll be x plus 7 or 7 plus x. So I want you to take a look at the right-hand column, and I want you to kind of look at it and see if something kind of stands out to you. Does order matter in addition? I want you to ask yourself that. Does 6 plus 3, is it different from 3 plus 6? No. And that's pretty much what I'm trying to get you to kind of see, is that 6 plus x or x plus 6 is going to be the same thing. It's just a different way to represent it, but it means the exact same thing, okay? Which won't be the case for subtraction or division. So we have to keep that in mind. So let's continue. So now we're going to talk about our subtraction phrases. So again, to the left-hand side, we have these vocabulary words. We have 4 of them. We have difference, minus, decreased by, and less than. And in the middle column, we have our examples of how we write them out. So the difference between 5 and a number tells us that we are going to be subtracting, so the difference, and we're going to be subtracting 5 and a number. And I want you to notice how we represent this. So 5 minus a number, or the difference of 5 and a number. Okay, notice how 5 comes first and then our variable. Okay, so going on to our next bullet point, we have 7 minus a number. And how do we represent that? Well, we would write 7 minus x. In the third bullet point, we have a number decreased by 9. A number decreased by 9 tells us that the number or the variable will come first. The decrease by tells us that there will be subtraction, and by 9 tells us by how much, okay? So this is how we would write it out. X minus 9. A number, a variable, decreased by 9. Going on to our last bullet point, we have 4 less than a number. So we're saying 4 is going to be subtracted from a number, okay? So how do we write that? That would be x minus 4, okay? Alrighty, so let's go ahead and move on to our next. Oh, do you notice anything about order here? Yes, order does matter in subtraction. So if you look at the second bullet point here in the middle, you have 7 minus a number. So notice how it's written exactly how it is explained in words. We write it in math. So we have 7 minus a number. We have 7 minus our variable. But this is different from, let's say, the third one, where we say a number decreased by x. So our number is going to be our variable. Decreased by tells us it'll be subtraction, and 9 tells us by how much we will be doing the subtraction. So if you look here in the third bullet point to the right, we see a number, which is our variable. Decreased by tells us it's subtraction, and 9. So these two things are very different. 7 minus x is different from x minus 7, and x minus 9 is different than 9 minus x. You will get a different answer, okay? Let's continue. So I want you to consider and really think about, does order matter? Does order matter in addition? Does order matter in subtraction? Does order matter in multiplication? Does order matter in division? We already talked about addition, and we said that in addition, order doesn't matter. So whether we add x plus 2 or 2 plus x, it'll be the same thing. So, but subtraction, order does matter. If we subtract x minus 2 versus 2 minus x, those two things are different. So let me go ahead and write that out for you. So if we have y plus 2, that can be written as 2 plus y. Okay? Whereas for subtraction, 4 minus x is not equal to something like x minus 4. These are two very different things. And I would actually encourage you to have some examples of your own, maybe plug in some numbers for x. Okay, so let's continue. Now I want you to think about multiplication. Would order matter in multiplication if we multiplied 4 times 2 versus 2 times 4, or 1 times 0, 0 times 1? Does order matter in multiplication? And the answer to that is no, order does not matter. What about division? If we were to divide 4 by 2, is that the same thing as 2 divided by 4? And the answer to that is that yes, order does matter in division, and it matters a whole lot. Actually, I think division and subtraction are probably the biggest places of confusion, but I think they're also the most fun and the most interesting. So, all right, let's continue. So we're also going to discuss our multiplication vocabulary words. So we have 3. We have product, times, and multiplied by on the left-hand side. And into the middle, we have our examples. So in the first bullet point, we have the product of 9 and a number. So our product tells us we're going to be multiplying of 9, and a number tells us we're going to be multiplying 9 and a number. And how would that look like? 9 times n, or really any variable. You could choose any variable here. It could be x, it could be y. Unless you're told specifically, you can choose whatever letter you would like. Usually x and y are pretty popular, and as well as t, things like that. For the next bullet point, we have 10 times a number, so 10, and then we have times. It tells me that it's going to be multiplication. So what are we multiplying? We're multiplying 10 and a number. So that would look like 10n. Okay. For the final bullet point, we have a number multiplied by 3. So our number could be a variable. Multiplication tells me, multiply tells me that it's multiplication, and how much we're multiplying by, they told us is 3. So this would look like 3 times n. So again, do you notice anything about order? Does order matter in multiplication? We just discussed that, and we said that no, order does not matter in multiplication. Okay, so now finally we're going to discuss our division phrases or vocabulary words, and we have 3 of them. We have quotient, divided by, and of a. And in the middle we have the examples of how we use them. So for the first one, we have the quotient of a number and 6. And to the left, we see here that this is how we express it. We have a number, so this is our variable, and it's going to be divided by 6. For the next bullet point, we have 7 divided by a number. So 7 is going to be divided by, this means division, and by how much? By a number. This would be our variable. So how would we write this? It would be 7 on the top. This fraction bar tells us it's division, and by a number tells us, that we are going to be using a variable. So we just write our variable n at the bottom. And notice how these two things are different based on how we phrase them in the bullet points, okay? And in the final bullet point, we have 1/4 of a number, And this is how we write it. We write 1/4 times n. Okay. Now again, do you notice anything about order? And does order matter in division? And we already said that order does matter in division, because something like, let me give you an actual example, something like 1/2 is not the same as 2 divided by 1, right? And I would also encourage you to take these examples here on the right-hand side and just plug in numbers for n. So write the reciprocal of this and just plug in numbers of n so you can sort of demonstrate to yourself that, in fact, order does matter for division, okay? And if you would like to see that, I could also create a whole video just about showing you how order matters in division and subtraction. So the best way to do this, the best way to learn how to translate phrases into variable expressions is to actually try it. So here is our example. We're told to write the phrase as a variable expression, and they are letting us know to let x represent the number. So here's our example, 11 more than a number. So I have 11, this is a number. More than tells me what? What is more than? What is this vocabulary word that we encountered? It tells us addition, okay? And a number, we were told, is going to equal x, okay? So I've actually outlined it. So more than is a sum or addition. Our number, we're told, is x. And addition order does not matter. So our final answer would be x plus 11 or 11 plus x, okay? Moving on, again, we're asked to write the phrase as a variable expression and to let x be to represent the number. So we have a number decreased by 10. So I am immediately noticing decreased by, and remember, where did we see decreased by? We saw it in subtraction. So let's break it down. Decreased by tells me that I'm dealing with subtraction. Number, we're told that this is going to be represented by x, a variable, and subtraction order does matter, okay? So our answer will be x minus 10, okay? So let's continue. Again, we're going to write the phrase as a variable expression and let x represent a number. So we have the quotient of 8 and a number. So just by reading this, I'm noticing this keyword right here, quotient. What does quotient mean? Where have we encountered the vocabulary word quotient? That's going to be in division, okay? And does division matter? Does order matter in division? Yes, it does. But what about a number? What are we going to write for a number? We're going to write x because we were told in the problem to let x represent the number. So Order does matter in division, so we have the quotient of 8 and a number. Think about it really quick. Which one will go in the numerator, the 8 or the x? Have your answer? Are you positive? Are you sure? Okay. So our answer is going to be 8 over, and that should be x. Actually, this actually should be 8 over x. Okay. So let's continue. So again, we're going to write the phrase as a variable expression and let x represent the number. So we have the product of 2 and a number. So just from reading it, the product is a key word, and that where have we seen product before? So that is going to mean multiplication. So what are we multiplying? We are multiplying 2 and a number. So what are we going to represent a number by? Our problem told us that a number is going to equal x. And does order matter in multiplication? Order does not matter. So we can write 2 times x or x times 2. Okay? So that is the end of our lecture for today. Next time we will continue to translate phrases, and we will also learn how to translate sentences into equations as well. I hope you found this helpful. Make flashcards for all of the phrases that we learned today. They would be really helpful. And for subtraction and division, I encourage you to look back at those and really demonstrate to yourself that order does matter. Okay, thank you so much for watching. I appreciate your time and attention. That is it for today, and enjoy the rest of your day.